Welcome to Algebra 1, Unit 7, Lesson 11, Practice Problems. This begins the second half of Unit 7 and will be the last section of material covered this school year. We start out with two vocabulary terms that will be important in understanding how to do these practice problems. The first term is perfect square. A perfect square is an expression that is something times itself. Usually we are interested in situations where the something is a rational number or an expression with rational coefficients. That leads into the next vocabulary term, which is rational number. A rational number is a fraction or the opposite of a fraction. Remember that a fraction is a point on the number line that you get by dividing the unit interval into b equal parts and finding the point that is a of them from 0. We can always write a fraction in the form a over b, where a and b are whole numbers, with b not equal to 0. But there are other ways to write them. For example, 0.7 is a fraction because it is the point on the number line you get by dividing the unit interval into 10 equal parts and finding the point that is 7 of those parts away from 0. We can also write this number as 7 over 10. The numbers 3, negative 3/4, and 6.7 are all rational numbers. The numbers pi and negative square root of 2 are not rational numbers because they cannot be written as fractions or their opposites. Now we look at the first practice problem. This says select all. Notice that all is bolded, so that means there can be more than one answer. So you need to check each choice and decide individually whether that is or is not a correct solution. Select all the expressions that are perfect squares. And remember, a perfect square is something multiplied by itself. So if we look at A, we have x plus 5 times x plus 5. The factors are the same, so this is a correct answer. Choice B, we have negative 9 plus c times c minus 9. While the order is the opposite, the factors are still the same. The c is positive in both factors, and the 9 is negative in both factors. So factors are the same. So B is also a correct answer. Let's look at choice C. We have y minus 10 times 10 minus y. The y is positive in the first factor, but negative in the second. And the 10 is negative in the first factor, but positive in the second. The factors are opposites. So this is not a correct solution. Choice D. We have a plus 3 times 3 plus a. While the order is opposite, we have a positive a in both factors, and we have a positive 3 in both factors. This means the factors are the same. Therefore, D is a perfect square. Choice E. We have 2x minus 1 times 2x plus 1. The 2x is positive in both factors, but the 1 is negative in the first factor, and it's positive in the second factor. So factors are different, therefore E is not a perfect square. Choice F. We have 4 minus 3x times 3 minus 4x. These factors are completely different. We have 4 in the first factor and 3 in the second factor. We have negative 3x in the first factor and negative 4x in the second factor. So again, factors are different. So F is not a perfect square. And choice G, we have a plus b times b plus a. While the order might be different, a is positive in both factors, and b is positive in both factors. This means the factors are the same. And G is also a perfect square. If you have any questions about how to determine whether it is a perfect square or not in factored form, please ask for clarification so that you understand before moving forward onto the other practice problems. Page 2. Each diagram represents the square of an expression or a perfect square. Number 1, complete the cells in the last table. So, if you notice, in the first table we had n times n equaled n squared. In the second table we had 5, and 5 was 5 squared. So in the third table, h times h is going to be h squared. In the first table, we had 7 times n was 7n. We had negative m times 5 was 5 times negative m. So in the third table, when we have h times 1/3, we're going to have 1/3 h. First table, we had n times 7. The answer was 7n. Then we had 5 times negative m, so we had 5 negative m. So in the third table, when we have h times 1/3, we're going to have 1/3 h. And finally, in table 1, we had 7 times 7 is 7 squared. In table 2, we had negative m times negative m was negative m squared. So in table 3, when we multiply 1/3 times 1/3, we're going to have 1/3 squared. Number 2. How are the contents of the three diagrams alike? This diagram represents term 1 plus term 2 squared. Describe your observations about cells 1, 2, 3, and 4. So cell 1 is term 1 squared. Cells 2 and 3 are the products of terms 1 and 2, meaning we're multiplying term 1 times term 2 to get cell 2, and we're multiplying term 1 times term 2 to get cell 3. And finally, cell 4 is term 2 squared. Number 3, rewrite the perfect square expressions n plus 7 squared, m minus 5 squared, and h plus 1/3 squared in standard form. So for n plus 7, we're going to have term 1 squared, so that's n squared. Then we're going to have the products of term 1 and 2, and we're going to have 2 of them. So we're going to have 7n plus 7n, so that's going to be plus 14n, and then we're going to have term 2 squared, which is 7 times 7. So that would be 49. Next, if we look at this second table, we're going to have 5 squared, which is 25. We're going to have negative 5m and negative 5m, so that's negative 10m. And then we're going to have negative m squared, which is going to be m squared. Negative m times negative m is m squared. And finally, if we look at this third table, we've got h squared. Then we've got 1/3 h and 1/3 h. So that would be plus 2/3 h. And then finally, we've got 1/3 squared, which would be 1/9. And number 4, how are the ax squared, bx, and c of a perfect square in standard form related to the two terms in term 1 plus term 2 squared? Ax squared is term 1 squared. Bx is 2 times term 1 times term 2, and C is term 2 squared. So if you learn this idea that a perfect square is simply going to be the first term squared plus 2 times term 1 times term 2 plus 2 term 2 squared, then you don't have to resort to FOIL anymore. FOIL would mean multiplying out the terms, combining like terms, and then getting standard form. But if you remember that a perfect square simply means looking at your term, knowing that you're going to take the first term and square it, then you're going to take term 1 and 2, multiply them together, and multiply that by 2, and it'll be your middle term. And then you're going to take term 2 and square it, and that'll be your last term. You can go straight to the answer without having to use FOIL. If you have any questions about this, please use class time to ask for further clarification now so that you understand completely what we're doing before we move on to the next practice problem. So bottom of page 2, they want us to solve each equation. And what I want you to notice is that in every one of these equations, the left side is a perfect square, and the right side is also a perfect square. So for number 1, the first thing we're going to do is take the square root of both sides. So this, if I take the square root of something that is being squared, all I have left is what's on the inside. So x minus 1. If I take the square root of 4, remember that we get 2 answers when we take the square root. This is going to be positive 2 or negative 2. In the first one, we would add 1 to both sides, and x equals 3. In the second one, when we add 1 to both sides, x equals negative 1. So those would be our 2 answers. Number 2, same thing. We're going to take the square root of both sides. Square root of something being squared results in x plus 5 equals 9, or x plus 5 equals negative 9, because 9 times 9 is 81, and negative 9 times negative 9 is also 81. We would subtract 5 from both sides, and x would equal 4, or we subtract 5 from both sides, and x equals negative 14. So it's important we remember that we have a plus and a minus answer when we take the square root. Number 3, again, we'll take the square root of both sides. This time, we're left with x minus 2, but we only have one answer because the square root of 0 is just 0. So when we add 2 to both sides, we find out that x equals 2. So notice when we're taking the square root of 0, 0 is not positive or negative, it's just 0. So when we take the square root is just 0. So there's only one answer. Number 4, we're going to take the square root of both sides. So now we have x plus 11. The square root of 121 is either positive 11 or negative 11. We subtract 11 from both sides. And we find out that x is either 0 or x is negative 22. So again, because we have square root of 121 being positive 11 and negative 11, we're going to have two answers. So we have two x-intercepts. And finally, number 5, we're going to take the square root of both sides. This tells us x minus 7 equals 8 over 7, or x minus 7 equals negative 8 over 7. Now I'm going to rewrite negative 7 as x minus 49 over 7. Now we're going to add the 49 over 7 to both sides. So we find out that x is either 57 over 7 or x is 41 over 7. So again, we took the square root of 64 over 49, and we got both positive 8 over 7 and negative 8 over 7. So that means we're going to have two answers, so we have two x-intercepts. I want you to keep in mind that if we take the square root of a positive number, we're going to have two answers and we'll have two x-intercepts. If we take the square root of 0, we're only going to have one answer, so we only have one x-intercept. That will be a crucial fact to keep in mind as we move forward throughout the rest of this class. To solve the equation x plus 3 squared equals 4, Han first expanded the squared expression. Here is his incomplete work. Number 1, complete Hans' work and solve the equation. So the next thing we would need to do is subtract 4 from both sides to set the standard form equal to 0. This would give us x squared plus 6x equals plus 5 equals 0. Now we're going to factor. We know that to get x squared, it must be x times x. The second symbol being plus tells me my signs are the same, and the first symbol being plus tells me both signs are plus. Now I need factors that multiply to 5 and add to 6, and that would be positive 5 and positive 1. Now I can set the first factor, x plus 5, equal to 0, subtract 5 from both sides, and get my first solution, x equals negative 5. Then I can set the second factor, x plus 1, equal to 0, subtract 1 from both sides, and get my second answer, x equals negative 1. Number 2. Jada saw the equation x plus 3 squared equals 4 and thought there are two numbers, positive 2 and negative 2, that equal 4 when squared. This means x plus 3 is either 2 or it is negative 2. I can find the values of x from there. Use Jada's reasoning to solve the equation. So if x plus 3 equals positive 2, then when we subtract 3 from both sides, we would find out that x equals negative 1. That matches the second answer from Hans' work. Then, if we said that x plus 3 equals negative 2, when we subtract 3 from both sides, we get x equals negative 5, which matches the first answer we found using Hans' method. So even though Han and Jada used different methods to solve, they both got the same answers. And number 3, can Jada use her reasoning to solve x plus 3 times x minus 3 equals 5? Explain your reasoning. So Jada's method was to take the square root of both sides. So no, her method will not work because x plus 3 times x minus 3 is not a perfect square. Her method will only work with perfect squares. If you have any questions about anything we've done on lesson 11 practice problems, please use class time to ask for further clarification now so that you are better prepared when we move into the lesson 12 practice problem.